Good morning, 8C. So unfortunately, because we are first thing in the morning and all of the morning classes have been turned into online lessons, so I have pre-recorded this lesson for you. It's a little bit unfair that we don't get the live Zoom lesson, but we have to do what it is. So let's continue today. Unfortunately, I don't have enough time to go through those problem-solving questions from yesterday. So we will move on to today's lesson, which is Disjoint Events 13.5. So first of all, we need to get some definitions out of the way. This is to do with our probability again, probability combinations and events and all that. So first of all, what is the meaning of disjoint events? So you might want to copy this down. Disjoint events, they are events in which no outcomes are in common with each other. No outcomes are in common with each other. Just a simple example, let's say I'm rolling a standard number cube, a dice. And so, for example, my events can be odd numbers, and even numbers. These are two separate events. I can roll for an odd number, I can roll for an even number, and they are disjoint because there are no single outcome that are in common. Odd numbers are odd numbers, 1, 3, 5, and even numbers are 2, 4, 6. There's no events that are in common. So odd numbers and even numbers, odd numbers and even numbers are disjoint events. So hopefully that is a fairly simple example to understand the meaning of disjoint events. Now, with disjoint events, there are also overlapping events. So overlapping is the opposite of disjoint. Overlapping events. And so with overlapping events, they are events that have at least one common outcome with each other. So for example, if I'm talking about the number cube again, I can roll for even numbers. So for example, even numbers, and I can even try for numbers. Okay, even numbers, and another event can be numbers greater than 3. These are two different events, and they are overlapping because with even numbers we have 2, 4, and 6. With numbers greater than 3, we have 4, 5, and 6. And so in terms of overlapping, we have two numbers that are overlapping, 4 and 6. 4 and 6, we call these overlapping, and so even numbers and numbers greater than 3 are overlapping events. Okay, so hopefully we understand the meaning. And so how do we usually show these types of disjoint events and overlapping events? We usually use a Venn diagram to show, to visualize the events. So we will usually we usually use a Venn diagram to visualize the events. So for example, if we're talking about disjoint, let me create our space over here. So we have event A, which was odd numbers. So we have odd numbers. So inside odd numbers, we have 1, 3, and 5. And then we also have even numbers over here. They're supposed to be the same size. This one is even numbers. And so inside there have 2, there's 4, there's 6. They are disjoint. So these are our two events, odd numbers and even numbers. So this is example of disjoint, J-O-I-N-T, I'm missing an I, events. And then with another example, I can use the same example as a while ago as our even numbers and numbers greater than 3. These are going to be overlapping events. And so first of all, with even numbers, what sort of even numbers are there? There are 2, 4, and 6, and I know that it's overlapping with the numbers greater than 3. Let me draw this slightly bigger like this. So here we have even numbers. I'm just going to do even numbers, just even, that's it, because I ran out of space. And then for over here, I'm going to put greater than 3. So just greater than 3 on this side. And so what are our events? Even numbers, there's 2, 4, and 6. But 4 and 6 are overlapping with numbers greater than 3. So I'm going to put 4 and 6 in the middle because it's overlapping. And 2 is going to be out here in the even. And then with numbers greater than 3, what's the only number that is left? That's going to be number 5. But in a number cube, there are 6 numbers. 1, 2, 3, 4, 5, 6. So in terms of these numbers, we left out 2 numbers. Where do those 2 numbers go? They actually go outside of both of these events because they're not part of these 2 events. They're just outside. So I'm going to go ahead and put 1, and I'm going to put 3 outside over here. It doesn't matter where you put them as long as they are outside the events. So hopefully we understand how to draw a Venn diagram. Let's go into an example. So example 1. Let's have a look at a number spinner. So we have a spinner. Let me draw a spinner, and it is split into quite a few numbers. There are 8 numbers over here. So we have 7, 15, 8, 3, 4, 6, 9, and 2. And so with this spinner, let's look at 2 events over here. Event P will be spinning an odd number. So to spin an odd number, oh, I forgot my arrow. So let's just say I have an arrow. Right now, it's at the number 7, but we can spin it, right? We can spin it. So event P will be spin an odd number. And then we have a separate event. Event Q will be spin a prime number. So we have 2 events here. Now, first of all, what I can do is I can list out the possible outcomes for event P. So in terms of event P, so example 1, we have event P, we have event Q. What is the question? We want to tell whether, okay, so find out whether the 2 events, events are disjoint or overlapping. And then we also want to draw a Venn diagram to visualize. So first of all, in order to find out whether there are overlapping or disjoint, we want to list out the outcomes for each of the events. So in event P, we have, what are all the odd numbers? Where are the odd numbers? We have 7, we have 15, we have 3, and we have 9. I'm just going in order of clockwise starting from 7. And then in terms of event Q are all the prime numbers. What are all the prime numbers? There is 3 is a prime number, 7 is a prime number over there, And I think that is it. And so we can see that within these two events, we have 7 that is overlapping and also 3 over here that is overlapping. So in the end, we can conclude that the events are overlapping. The events are overlapping. Then what we want to do in the next part is draw a Venn diagram. So I'm going to go ahead and draw a big box over here, and I'm going to draw 2 large circles like this. And then this will be event P. Let me just label it P. And then this will be event Q. And so what are all the numbers? Well, first of all, what are the overlapping numbers? That's 3 and 7. So I know that 3 and 7 go in there. Then what are the other numbers that go in event P? There is 15 and there's also 9. And then Q is actually, whoops, I kind of drew it wrong this time because Q is only 3 and 7, which means that it's not just overlapping. Q is actually inside P. So if we think about it carefully, let me draw this circle slightly bigger over here, and then I would draw another circle. That's going to be 3 and 7. Q is inside P because all of event Q is part of the event of P. So we would actually draw it inside. So we have to think it carefully through. So I have the luxury of being able to erase it easily, but if you're drawing, you have to think it through before you actually draw. And then what are the other numbers in the spinner that are not in our diagram so far? So we have all the prime numbers, which is 7, 15. Then there's 8. 8 will go outside. There's 4 that will go outside. I can put that over here. Then there's 6. I can put that over there. And there's 2. I can just put that over here. So those are all the numbers in there. So this is disjoint and that's overlapping. So let's do one more example. I need to, okay, we can talk about the probability of disjoint events. So let me just quickly copy the question. I think it's probably easier if you can see the question below. Now, before I go into the next example question, is I need to talk about something called probability of disjoint events. So this will be the next subsection, probability of disjoint events. The probability of disjoint events, if 2 events are disjoint, meaning that they have no single overlapping outcome, then the probability of event A or event B happening is the sum of their probabilities. Okay, so if 2 events A, B are disjoint, okay, then the probability of event A or event B happening is the sum of their probabilities. So if they're disjoint, so for example, let me talk about my simple probability. So let's say e.g. so I roll a number Q. So roll a number Q, and let's say event A will be even numbers again, even numbers, and then event B will be greater than 3. And we all know we've done that a while ago. So even numbers, that will be 2, in terms of that, that's going to be 2, 4, and 6. And event B, that's going to be 4, 5, and 6, right? Now, these are overlapping, so I cannot use these two again. So even numbers, and let's just say prime numbers. Prime, oh no, 2 is a prime number, so I can't do that. So event B, let's just say, is multiples of no. Let's just do odd numbers this time. Simple. Odd numbers. And so the meaning of I want to find the probability of either rolling an odd number or an even number, and we know that's going to be 100% because you either roll an odd number or an even number. That's going to be 1, 3, and 5. But they are disjoint, meaning that the probability of rolling an event A or B is going to be, that's going to be half plus half, which is 1. So this is a very simple example over here. It's not the best example because it's either even numbers or odd numbers, but let me use a better example. Let me just say in our, let's say I want to quickly make up an example. In a spinner, I have 2 events. So in a spinner, let's say we have over here 8 over here, and let's just say we have the numbers 3, 4, 7, 9, 11, and then we have 15, 16, and we have 18. I just made up these random numbers, and so event A is rolling multiples of 3, multiples, spinning, sorry, it should be not rolling, spinning, multiples of 3, which are going to be multiples of 3 will be 3, 9, 15, and 18. And then I want to do event B over here. Then event B, let's just say we want multiples of 4, because I don't think they overlap in this scenario. So we have spinning multiples of 4. Now it just works this time because there is no 12 in this example, because if there are, 12 will be overlapping, but since there's no 12, there is no overlapping events, which means that they are disjoint. So these 2 events are disjoint. So if I want to find the probability of either A or B, I'm satisfied with either spinning a multiple of 3 or spinning a multiple of 4. So the probability, and we usually write it this way, the probability of 2 events, probability of A or B, will be equal to the probability of A plus the probability of B, if they are disjoint. Okay, there's no overlapping events, then it's going to be the probability of A happening plus the probability of B happening. And so in this case, probability of A will be 4 out of 8. And the probability of B happening is 2 out of 8, which means in the end, that is 6 over 8. And how many highlighted over here? There's 6 numbers highlighted, and that's the probability of those 2 happening. And we can simplify them. 6 out of 8 is the same as 3 over 4. So 3/4 of the ones are either multiples of 3 or multiples of 4. So let's now look at an example question. Let me copy the question and let me paste it over here. So arena events. The table shows the probability that an arena event is of the given type. What is the probability that a random chosen event is an ice hockey game or a basketball game? Now, these are disjoint events. So first of all, these are all disjoint events. There is no overlapping outcome. There is no ice hockey and ice show that is the same. The arena is either an ice hockey game or an ice show event. It's not a combined. There is no I can't even think of what will be an overlapping event in this case, because they're all different. So if these are all different, then the probabilities will be the sum of the 2 probabilities. So what is the probability of, we're looking for hockey game game, or basketball game, and this is the same as the probability of hockey game. I'm just going to say hockey plus the probability of basketball, because they are disjoint. And so the probability of hockey game happening, that's going to be 23%, plus the probability of a basketball game happening, that's 24%. So we need to add the two percentage together. That's going to be 47%. That is adding disjoint events together. The probability of disjoint events. So either this or that. So quick note, long story short, if we're looking for A or B, the probability is equal to probability of A plus probability of B. If A and B are disjoint. So this is what probably an important part of today's lesson. We need to understand that disjoint events means that there's no overlapping events, no overlapping outcomes inside. Then, if we're looking for either A or B, then it's going to be the probabilities add together. Now, last term will be, we have something called complementary events. So the last term I want to mention, I know this lesson is running quite long, it's 21 minutes, but last point. So complementary events are two events that make up all possible outcomes. Two disjoint events that make up all possible outcomes. That is complementary event. So for example, e.g., in a dice, rolling odd numbers and even numbers are complementary because they make up all the numbers. 1, 3, 5 plus 2, 4, 6, they make up all 1, 2, 3, 4, 5, 6. And also, we can write it in this way: probability of A plus probability of B, if that is equal to 1, that means that they are complementary. That means that they are A and B are complementary. There's also different ways of writing this. So for example, if A and B are complementary, then I can find out what the probability of B is. So for example, probability of A is equal to the probability of B minus, 1 minus probability of B. 1 minus probability of B. I can write it this way. Or I can write it in another way. Probability of B happening is the same as 1 minus probability of A happening. So this all happens if A and B are complementary. Let's look at an example. Let's look at an example over here. Out of 267, I don't know why they came up with this number, 267 students, only 3% know sign language. So knowing sign language and not knowing sign language are complementary. Let me just make a note over here. Knowing sign language and not knowing are complementary. And so I want to find out how many students do not know sign language. And so first of all, I can find the percentage that do not know. So the percentage that do not know, is equal to 1 minus 3%. That is going to be 97% of the students that do not know. And then what I have to do now is multiply that 0.97 times that by 267 students. So that's going to be 0.97 times 267. And so that is 259, because it's 258.99, which is the same as 259. So that's 259 students that do not know sign language. So that is it for this lesson. I know it's been a very long lesson. And so what I want you to do for your homework is exercise 10.5. Sorry, not 10.5, 13.5. And then I want you guys to try and do all the odd number questions up to 32. So all even. So all even questions from 2 to 32. So that's no problem solvings. We'll try to do some problem solvings next lesson. So I know it's been a long video, I know it's been a long lesson, but thank you for watching. And if you know you have some friends who probably aren't going to watch this, please force them to watch this, remind them to watch this. They need to learn this. Okay, thank you for watching, and see you all next lesson.